Hello everyone, welcome to Tech with Machines. Today's topic is Spark core concepts. We are going to go through different fundamental concepts which are used in Spark core's module, and we'll also go through the differences between each of them wherever it's applicable. So without any further delay, let's start. So the first concept and the fundamental concept in Spark is going to be a very common asked question in interviews as well, which is data sets versus data frames. And if you are acquainted with Python pandas, then you might already know what data frames are. And if you are acquainted with compile time safety checks, then you might be able to better understand what data sets are. So first of all, both are high-level abstractions in Apache Spark's core module. They're used for structured and semi-structured data, whereas RDDs are generally the lower-level APIs of Spark, and higher-level or structured APIs of Spark actually are provided by datasets and data frames, right? Both of them are distributed collection of data, but in data frames, they are generally organized into named collections. It has a defined schema that defines the data types and names of columns, and this makes them suitable for processing structured data. Whereas dataset, on the other hand, has a strong type safety and has object-oriented features. It's well used for functional programming or the cases where the type safety is really important. So it becomes more performant than data frames for the tasks which actually need the type safety. Data frames, on the other hand, are performant over for common operations because they are more user friendly and they are more confined to SQL syntax. So if you are familiar with SQL syntax, then you might find data frames more user friendly comparative to data sets, where data sets generally are more suitable for users who prefer strong typing and functional programming features. So in nutshell, data frames are suitable for more structured data processing tasks and are widely used due to their use of easy use and optimization. On the other hand, datasets offer strong type safety and performance benefits for complex data processing, which makes them ideal for applications that require fine-grained control over data manipulation and type safety. So those are the key differences between data sets and data frames. You might find many other differences as well, but these are in summary, the differences between data sets and data frames. In general, data frames are available in mostly in all languages of Spark. It's in Scala, it's in Python, it's in R, right? But whereas data set you will find only in the language which supports the compile time safety checks like Java, for that matter, and Scala, right? Python, on the other hand, is a dynamic typed programming language, so data frames are more preferable choice in Python comparative to data sets. Yeah, that's pretty much about data sets versus data frames, and this is, as I mentioned earlier as well, this might be one of the most commonly asked questions in interviews. Let's talk about Spark context versus Spark session. We are going to go and explore each of them in details and also understand the key differences between each of them. They're very important concepts and they play different roles in managing and interacting with Spark applications. In our previous video, we talked about Spark context, which is a main entry point and context handler for interacting with Spark. But this was in earlier versions of Apache Spark prior to Spark 2.0. After Spark 2.0 and higher versions, it's Spark session, which is an enhanced and unified entry point for interacting with Spark, and generally was introduced in Spark 2.0. In terms of usage, Spark context generally is used for low-level Spark programming, especially RDDs. It deals with RDDs, and it used to be manually created we had to create a Spark context object manually to interact with Spark features. It generally involved specifying Spark configuration options and setting up the application environment. Whereas on the other hand, Spark session is automatically created when we launch a Spark application. So that's the improved version over Spark context. And Spark session also has access to Spark context because it is combines the functionalities which were previously handled by separate context, one of them being Spark, SQL, or Hive, right? So these are the main key differences between Spark context and Spark session. One of the other differences is that Spark session also offers capabilities for reading data from various sources, be it files, databases, streaming sources. It performs ETL operations, it executes SQL queries, and it interacts with Spark's built-in functions and libraries. So key comparisons are initialization, are the functionality which each of them provide, and Spark session on the other hand being a unified entry point and can be multiple per JVM, whereas Spark context has to be typically one per JVM. So that's another key difference between Spark context and Spark session, which is worth noting. Another key concept in Sparks are RDD. You might have heard about it, and if you have not, then let's go through and explore this. So RDD stands for Resilient Distributed Dataset. It's a fundamental abstraction in Apache Spark that represents a distributed collection of immutable, partitioned, and fault-tolerant data items. It's a backbone of Spark's distributed computing model, and it provides a resilient and efficient way to perform parallel data processing across a cluster of machines. Now let's deep dive into the details of RDDs. So I have kept here a few key features and capabilities of RDD so that you can remember what really RDD has as a capability. Firstly, it's immutable, which means once you create it, its contents can't be modified. It's a general definition of immutability. And any transformations which you apply to an RDD, which are operations performed on a data frame or a data set, they result in the creation of a new RDD, leaving the original RDD unchanged. Immutability is ensuring that there is a data consistency, and it simplifies the fault tolerance and parallel processing. Second, it is distributed, of course, because it is distributed across multiple nodes in a cluster, and it allows for parallel computation. It does allow data partitioning, which are processed independently and in parallel, leveraging the computing resources of the cluster. Then another key feature of RDD is resilient. They are resilient to failures, and they can recover lost data partitions using their lineage information. Lineage generally refers to the sequence of transformations which you apply to an RDD, which Spark reuses to reconstruct lost partitions in case of failures. We'll go through those lineage information or how the transformations are applied to an RDD in a few more videos in the series. But that's the general definition of resilience which RDD provides. Another thing is that it provides a dataset abstraction that represents a collection of elements distributed across a cluster. Elements in RDD can be of any data type, including primitive types, custom objects, tuples, and collections. They are lazily evaluated. They are lazily evaluated, meaning they are not executed immediately. So basically, what Spark does is it builds a DAG of transformations when operations are applied to an RDD, and actual computation only occurs when an action is triggered. So that's what clearly defines transformations and actions in RDD. Certain operations which are transforms an RDD to a new RDD, and then if you want to collect or execute an action on that transformation is called an action, and it's another operation. So in a nutshell, transformations and actions are also another key concept in Apache Spark, which we'll cover in just few minutes. So this is what lazy evaluation means in Spark. It actually optimizes the performance by allowing Spark to optimize and fuse operations before execution. And this is generally been asked that what does lazy evaluation of an RDD mean in interviews. As we said that Spark is resilient, which means fault tolerance is by default. So that same thing, it achieves fault tolerance through lineage and resilient storage options, which allows it to basically recompute lost partitions by tracing back the transformation applied to an RDD. RDDs can be persisted in memory, or they can be persisted only on disk, or they can be persisted in both, which allows to do multiple performance trade-offs and helps to achieve fault tolerance. Now, transformations and actions are two types of operations which are performed in RDDs. Transformations generally create new RDDs from existing ones, while actions perform computations and return results to the driver program. So that is what transformations and actions mean. Now, there are multiple examples of transformations and actions which are performed in RDD, which we will explore in coming videos of this series. In nutshell, the RDDs are accessible through APIs in multiple programming languages like Scala, Java, Python, and R. And each language API provides methods and functions for creating RDDs, applying transformations, executing actions, and managing distributed computation tasks. So, in summary, RDDs provide a distributed, immutable, fault tolerant, and lazy evaluated abstraction for processing large scale data in parallel across a cluster. They are or they serve as foundation for higher level abstractions like data frames, data sets, and structured APIs in Spark, which does enable efficient and scalable data processing applications. So this is what in nutshell Spark core concepts really mean, or are the foundations of Spark core. We will do transformations and actions in next video, where we will also do a exercise to understand really what transformations and actions are. I would basically in the next video go through Spark in Python, and generally I'll use Jupyter Notebook to do the hands-on exercise. So if you are not comfortable with Spark Notebook, then I can actually help you to download Spark binary and submit an application, Python application directly using Spark Submit. But in the next one, we'll mostly go through Jupyter Notebook and do an exercise with certain examples which can really explain what transformations and actions are. That's it for today. Thank you for watching, and I hope this video helped you to understand the basic core concepts of Apache Spark. Thank you.